Thank you.
Okay. All right, so let's take a look at this one. A, B, and C, we ought to fly right through. And then part D is where the new lesson is going to be starting. So real quickly, we're going to run through A, B, C. And for part A, it says give the x coordinates where f has a relative max. So to translate real quick, you're looking at the graph of the derivative. So A, B, and C is a problem you've done a whole bunch of times before, right? So for part A, the relative maximum, your answer should be that there is a relative maximum at x equals -2. So that would get you the first point. Second point is going to be your justification, and your justification should be because f prime of x changes from positive to negative. So you need two things. You need the answer and you need a justification. So max at -2, and the reasoning is because f prime changes from positive to negative. Okay. For part B, on what open intervals is the graph both concave down and decreasing? If it's decreasing, it's underneath, okay? And then if it's concave down, that's a negative slope. So you should be looking at the intervals from -2 to -1, and also from 1 to 3. From -2 to -1, and from 1 to 3. And then your reasoning for that is because f prime of x is decreasing and negative in either order, negative and decreasing over those intervals. Does anybody have any questions on A or on B?
Mr. Baker,
Yes.
this is not about the problem, but is this the same like lesson, the Fundamental Theorem of Calculus lesson that we did at 3:30 yesterday?
Yes.
Because I already have this one recorded.
Okay.
So
Whatever. You can. We might get it. We're gonna probably get a little further today, so you can go
Okay,
ahead.
I'll keep recording.
Yeah, we'll keep recording, and this is one of the most important
Yeah.
lessons of the year, so it's worth kind of getting a few versions of it on video. All right, part C, we ought to be good there. X coordinates are the turning points, and then remember when you do the turning points, you want to group them by the way that they turn. So we want to group -1 and 3 together, and then we want to group 1 together. So at -1 and 3, it's a point of inflection because f prime of x changes from decreasing to increasing. And on the other one at 1, it's because it changes from increasing to decreasing. Okay. Does anybody have any questions there? All right. So then part D starts the new stuff. So this was taught at 3:30 yesterday. It was supposed to be taught at 7:30 last night, but that class fell through. So we will be starting this right now. So I'm going to stop the screen share for a minute and just kind of run you through some stuff here. So let's do that. Give me 1 second. I've been talking to myself for 2 minutes, so I'm on mute. That would explain why you're not answering. All right. If I integrate f prime, what do I get?
F.
Get f. All right. So now we're going to change this a little bit. So we've already kind of previewed the fundamental theorem. So we're going to make this proper now. So it's f prime of x dx, and we're going to put some bounds in. So if you were to integrate this, hopefully it makes sense to say that you're going to get f of x, and there's your bounds. And then if we plug them in, it's going to be f of b minus f of a. Okay, so translation, the integral from a to b of f prime of x dx is equal to f of b minus f of a. That right there is the big formula. And that should make sense because we've kind of been previewing that for a while now. And if you were to look that up, it is called the Fundamental Theorem of Calculus, also known as the FTC. If you look them up on the internet, you will see all kinds of stuff on it. But more or less, that's the gist of the formula. So hopefully that makes sense. And then we're going to use that to find some stuff. So does anybody have any questions first on that formula? Okay, so when it comes to this formula, we want to think of it as having three pieces. So I'm going to think of this as A equals B minus C, or X equals W and Y, or X, Y, Z, or whatever three letters you want. Just picture these as three blocks, three pieces that can move. So the first part is the integral, second part's f of b, and the third part's f of a, and we can move these pieces around. In other words, if I wanted to solve for one of these three, I could move the other ones around to isolate it. Okay, so let's just keep that idea in our mind, and then I'm going to flash back down to the problem. Okay, so we are at part D. Okay, part D. It says, given that f of 1 is equal to 3, write an expression that finds us f of 4 and f of negative 2. So this is two entirely different problems. First off, f of 4, that's a problem. F of negative 2, also a problem. So for right now, we're just finding f of 4. Okay, so anytime you have something involving the derivative, you have the graph of the derivative, and they ask me to find something about f, or the original. Hopefully it makes sense to say that we want to integrate that. So if I integrate f prime of x, it's going to get me back to f. So that's a good start because we're trying to find f of 4. Okay, so here's how the fundamental theorem works. You need to know one of the bounds. Good news for us, they tell us that. F of 1 is equal to 3. So I'm going to make one of my bounds 1, and I'm going to make my other bound 4, because that's what they tell me to find. Remember, two different problems. We'll worry about the second part later. So to do the fundamental theorem, one of the bounds has to be given to you and you know it. One of the bounds you're looking for. Okay, so if we integrate this and follow along, if we integrate f prime, we're going to get f of 4 minus f of 1. Everybody good? Okay, what are we solving for, guys?
F of 4.
And what do they give us?
F of 1.
F of 1. Okay, so does it make sense to say that this is equal to f prime of x dx? 1, 2, 4, it's equal to, we're looking for f of 4, and we know that f of 1 is equal to 3. Okay, and we're trying to solve for f of 4. Remember, I told you, think of this as a equals b minus c, and you're being told to solve for b. So does that make sense to say that I'm going to add c to the other side? I'm going to add 3 to the other side. So this is now 3 plus the integral from 1 to 4 f prime of x dx is equal to f of 4. What's the last thing I need in order to solve for f of 4? I need to know what is equal to. putting a box around it so that we can say it.
The integral of
Need to know what the integral is. Okay. I need to know an answer for this integral. What are all the ways that I have to evaluate an integral? I can either be given a formula and I can do actual integration. I can be given something that I can do Riemann sums with, or they can just tell me. So we got to go up to the problem and read, because look at these things. We're trying to find the area from 1 to 4. I'm trying to find the area of inside of that shape there. So it's not Riemann summable. It's not a formula that I can use. So the only other thing is, well, they can just tell me. So we just read right here the problem, see what it says. The areas on the graph of f prime from -2 to 1 and 1 to 4 are 9 and 12 respectively. That means this area over here is 12. But since it's underneath the x-axis, what are we going to make it? What kind of 12?
Negative.
You got it. So it's 3 plus a -12. Final answer, -9. Does anybody have any questions on that? Okay, you've got 2 minutes, 2 to 3 minutes. Find me f of -2. Go. Find f of -2. All right, who can walk me through this? How do we find f of -2? Start from the beginning. What are we doing?
I can try this one.
Go for it.
Let me find it on my paper. Okay. So we have f of 2 equals 13.
No, I want to walk me through the whole thing.
Okay. Now I'm trying to find it in my paper. Give me a second.
You're good. Just tell me what you did. We're integrating, right?
Yeah, correct.
Okay, what are we integrating?
So we're integrating, can I see the question really quickly?
Mhm.
Okay, so the integral from -2 to 1,
Mhm.
f prime of x dx, and then that equals f of 1 minus f of -2,
Okay, which one are we solving for?
f of -2.
Okay, so does it make sense to say that we're gonna move that one to the left?
Yes. Well, so I ended up doing f of 1 minus the integral, and then that equals f of -2.
Yeah, it's the same thing. Right?
Okay, got it. Yeah. So yeah,
if A equals B minus C, so somehow or other I just want to solve for C.
right,
Okay, so that's like saying C equals B minus A, right?
correct.
Okay, so that would be F of -2 is equal to F of 1 minus the integral you just talked about. All right, still good?
Yes.
Okay, next, what do we do?
So after that, I plugged in f of 1, which was 3.
Mm-hmm.
And then I kind of skipped around here, but after that, you would do the integral from -2 to 1.
Yep.
When I did that, or I looked at the description, it said it was 9, but because it's below the x-axis, it's -9.
Mm-hmm.
So
what's
then
my
that would be 3 plus 9 essentially, and then f of -2 equals 12.
good? Looks good to me. Do we have questions? Everybody in chat that made sense to?
Wait, I have a question. So I did, because it said that the interval was -2 to 1, so I did f of -2 minus f of 1.
Hold on. So which way do your bounds go? Which one was on the top?
-2, because
Okay.
it said like, in the question it said that that was first.
Where did it say that it was first? Explain that to me.
It said the areas of the regions bounded by the x-axis and the graph of f of whatever on the intervals -2 to 1.
Oh, okay. I get what you're saying. Okay. So here's a lesson to remember. Think of it this way. When we do this, it's always B and A, right? For whatever, F of X or F prime of X or whatever. Think of B as B for bigger. Whatever the bigger bound is goes on the top every time. So
Okay.
it doesn't matter what order anything's given in, whatever. You always want your bigger bound on the top. So whatever it takes to memorize that, B for bigger, bigger bound on the top. Okay. Any other questions? Okay, then let's try an example. See how we do. Give me 1 second. Okay, so we will call this the graph of f prime. Okay, off you go. F of -3 is equal to 11. Find us f of 4.
Mr. Bigger, I have a question.
Yes, what's up?
So when you're finding the area, under like the line, if it's below the x-axis, does that just mean that it's negative? And when it's above?
That is correct.
Okay, thanks.
Mhm. Okay, guys, so let's set up our integral. So Taylor, you want to keep going? Tell me what you did.
Oh, sure. Okay. So I did the integral of 4 and then -3 at the bottom. So f prime of x and then dx equals f of 4 minus f of -3.
4 minus. Cool if I do that. Not starting to make connections now that we don't, I'm just trying to save you some writing. So once it starts to click, instead of writing f of -3, we can just plug it in as we go.
Right.
Okay, next.
And then you add 11 to the side with the integral.
Okay, so that's -3 to 4, f prime of x dx is equal to f of 4. Okay.
And then you find the area. So under the line, which, so because it's a triangle for that like first little bit, you would get -6. Oh, I did it like 2 separate triangles.
That's cool. What'd you get for the first one?
For the first of that bigger triangle, I got -6. Oh wait, no, did I mess up?
Area of a triangle is base height, cut it in half.
Yeah, no, like the y-axis is cutting them both in half. Yeah. So
Yes, so we're looking for just this triangle, right?
yeah,
Okay, so what'd you get?
wouldn't it be 3 times 2 divided by 2?
Yes, so what is that?
Oh, 3. I don't know why.
Okay, okay, there we go.
Sorry. I don't know why. Okay, I
You're
messed
good.
it up, but okay. Sorry about that. Okay.
You're good.
And then the next one would be 2.
And what do we got over here?
Right?
You
Because
cut, so you cut out, say again?
sorry, the next one would be -2, right?
Yeah, so this is 2, and that's 3. So we've got a net result on the bottom of either -3 and -2, or if you did one triangle, -5. Okay, what do we got up top?
And then so the base would be 2 and then the height would be 3, so it would be a total 3. So
Okay, so the net result of all of this is what?
-2.
Yeah, so think of those as wiping out, and then you've got -2. So what do we get then for a final answer?
Oh, okay. Wouldn't it just be 9?
Yep. So we would come up with 9 for a final answer. Okay. So you're going to start to see a lot of patterns. This problem will repeat itself. You will see this skill used a lot. The only thing that will really change in these problems is how do you come up with an answer for the part I just circled. So we've done a problem now where they just flat out tell you. We've done a problem where you got to do some geometry and you can get your answer that way. They can give you an actual formula that you integrate. And then the last way to do this, which we're going to look at next, is through Riemann sums. So now, before we get into Riemann sums, let's think about some other variations of our FTC problem. So right now I've been saying, all right, whatever my bounds are, I'm going to integrate f prime of x dx, and that's going to give me f of b minus f of a. Okay, another way this problem can happen is, what if we're not talking about f prime and f, What other two functions would come into your mind that would be very likely to fit this pattern? Think. Instead of f prime and f, what else could we call them? What kind of problem? What's another way of saying the derivative? You know the answer to this. What's another way of saying the derivative?
Average rate of change.
I don't know if that's the derivative. Think about our different meanings for the derivative.
Like a rate of something, or
Getting warmer,
I mean the slope.
getting colder. Derivative, also known as we did word problems with these.
related, right?
Instantaneous rate of change. Yeah, that's a true statement, Caleb. Well, I'm thinking of velocity, right? Isn't another way of saying the first derivative of velocity? So if we say via t dt, what do you get when you integrate velocity?
Position.
Exactly. Super important that these make sense as being the same thing, depending on what kind of problem you're talking about. So if you integrate velocity, we head backwards to position. Does that make sense, guys? Okay, so with that in mind, let's read the following free response. And disclaimer, don't freak out. It's going to throw you for a loop. Difficulty level is increasing rapidly. So you don't have to ace this. We just got to start to get comfortable with doing problems of this sort. So, all right. So I'm going to give you a second to just read this. Take 30 seconds and just read the problem and get acclimated. Go. All right, so we're talking about a train. The train's moving east and west on a section of track. All right, talk to me about part A. What are we doing?
Would you take the derivative of the velocity?
For part A, it says to find the average
the second.
acceleration. Just going to find the what? Say it again.
The second derivative?
Average rate of change, average acceleration. What are we finding?
The slope.
You got it. So think of it this way. Almost every part A, if there's a box of data, I don't know that I've ever seen a box. I call these box problems because they give you a box of data. Every box problem you ever do, I think part A asks you to find the slope. So just keep that in mind because they're pretty consistent with that. So for part A, we'd want to say the average acceleration is approximately equal to, we're doing 2 to 8. So negative 120 minus 100 over 8 minus 5 is negative 220 over 3. What did I do wrong? 8 to 2, not 8 to 5. So how about that would be 6, and then that would be negative 110 over 3. What are we talking about? Meters per minute squared. Any questions on part A? Okay, part B, we are going to be skipping. That's a lesson I need to teach you another day. Part C, though, ties directly into what we were just working on. So taking a look at part C, it says at time equals 2, train A's position is 300 meters east of the origin station, and the train is moving to the east. Write an expression involving an integral that gives the position of train A in meters from the origin station at time equals 12. Use a trapezoidal sum with 3 subintervals indicated by the table to approximate the position of the train at t equals 12. Nobody understood a word that I just said. I understand that. Okay, so first things first is that you got to be comfortable taking a paragraph of writing like this and just plucking out the things that matter. So the first thing that matters is they're telling me something about t equals 2. They're giving me the position at t equals 2. The position is 3. All right, so now how do we actually write that? We don't want to scribble all those words. What's the math version of that? At t equals 2, the position is 300. So how do we write that out math-wise?
F of 2 equals 300.
Very close. Instead of F, what do we use, though, for position? Or, yeah, for position. What letter?
Yeah.
2.
Yeah, so x of 2 is 300. Got it. All right, we keep reading. Write an expression that gives the position of train A at t equals 12. Does that make sense that the answer to this question is x of 12 equals what? That's what we're hunting. That's what we're trying to find out. Okay. So you want to just go one little piece at a time, pull out what you can understand, and just jot it down, and then we'll make sense of it. Okay. So I know x of 2 and I want x of 12. Immediately, things should start be going off in your head saying, oh, they gave me a bound. They want a bound. I know something about 2. I want something about 12. Position is what I get if I integrate velocity. Good news, I have a box of information about velocity. So things need to be starting to click in your head that this is FTC, fundamental theorem. Integrate the velocity, I'm going to get position. It's the same problem we were just talking about. Okay, so now it says use the integral or set up an integral to find this answer, and then they give me some direction at the end. Use a trapezoidal sum, yada, yada, yada. They're telling you how to estimate or how to get your answer for the integral piece of the problem. Do you guys think I've said enough that you could try this on your own?
Yep.
All right, try it. We got about 3-4 minutes and we'll talk. Okay, who wants to try it and talk me through it? It's okay to be wrong. Somebody try it, talk to me.
Okay, so
All right, what are we doing?
so first I started off with the integral of v of t, the velocity, and with the bounds 2 and 12.
Just as a little note, make sure it's dt whenever it's a t for a variable. So via t dt. With you, next.
And then equals x of 12 minus x of 2.
Got it. Next.
And add x of 2, which is just 300. So plus 300 on the other side. And then I took the trapezoidal.
Trapezoidal.
Okay, sum, and ended up. I don't have to like go over.
I don't care. Tell me what you got. What'd you get for the trapezoidal sum?
I don't know if this is right, but negative 3,080.
Whoa, that's a big number.
Oh, okay. No, I must have messed up.
All right, so hold on here. So let me ask you this, Taylor. How many trapezoids did we do?
I did 4.
Okay, so there's your problem. So check it out. Check it out now. Where do our bounds?
Right. Oh my gosh.
So that's okay. So the only thing that you're doing off here is we want to exclude this one. So that's not going to be part of the puzzle because so you always want to take a glance and say, okay, so here's the piece that I need to figure out. What am I actually figuring out? I'm figuring out the integral from 2 to 12. So you would just want, that would be 1, that would be 1, and then that would be 1. Make sense?
Mm-hmm.
Okay, so then tell me your sum for trapezoids 2, 3, and 4.
2, 3, and 4. Okay. It was negative for the first one. It was negative 300.
So what's our total for all 3 trapezoids?
Oh, for all 3. Okay. Sorry, 1 second. Okay, I feel like I'm gonna get this wrong again, but okay. Negative 3,180. I did something wrong.
Okay, so let's examine here. Let's get some trapezoids drawn and see what we're working with. So here's our first one. Here's our second one. There's our third one. Okay, what's the bottom for the trapezoids? What do we got?
For the first one, I got negative 60, right? Because you're going from 100 to 40.
Whoa.
Wait.
These are your x values up here.
Oh my gosh. Okay, that explains.
Always remember, time is always the x. Height is always the whatever we're talking about.
Okay, sorry about that.
You're good. So does 3, 3, 4 make sense?
Yeah.
Okay, so that would explain why your numbers got so big. All right, so now what are we doing for the heights of these? We're gonna do what? 100, 40, 40, negative 120, negative 120, negative 150. So you want to add up the bases, cut it in half times the height. Add up the bases, cut it in half times the height. Add up the bases, cut it in half times the height. Somebody that thinks they got it, tell me what you get when you do all that.
I got negative 450.
You got it. So those 3 are negative 450. All right. So now that we know that, you've got 300 plus negative 450 is x of 12. That gives us an answer of negative 150 is equal to x of 12. All right, now, good news, you got an answer, and it's correct, so you're getting credit. Bad news is we're not done yet. When you're doing these FTC problems or any integration for that matter, and it's with relation to a word problem, we got to explain what that answer means. So does anybody think they know what negative 150 means in relationship to this problem?
I'm just gonna base this off what I learned in physics, but I think it would it be that, are we talking about velocity or position?
What's X? We got X, right? So
The
X
X
is position.
position. So then would it be 150 meters to the left?
Yeah, exactly. So what do we call that? Which direction are you heading if you go to
Backwards.
California?
So backwards position, like left.
Which way are you heading if you go to California?
West.
Okay, here you go. So you can see in the problem, if it was a positive position, it was heading east. So I don't know, I always just picture Atlantic Ocean and California. So if you're heading to the east, the train's heading towards the Atlantic Ocean. And if your position's negative, then it's heading to California. So in terms of this particular problem, you would want to answer this and say, the train was, so the way they were describing this is they were saying basically, here's a train, here's the train station, and the train exits this station. It either goes that way or that way. So if it's heading this way, it's heading to the ocean. If it's heading this way, it's heading to California. So when it was at 300, it was 300 to the east. And now that you're at negative 150, think of this as just like a big number line. You're 150 meters towards the west. So we're actually going to say it's 150 meters towards the west, or 150 meters west of the train station. Okay. Okay, so that doesn't have to be perfect right now. That's a lot of calculus for a random Wednesday night. I think you could probably take a hint though, that this is one of the most important lessons of the year. And this pops up in a million different places, in a million different free response problems. So get comfortable with it. You're going to be seeing it a lot. Any questions?
I have a question. Would these, like, will they ever include trig, or is it just these types?
Oh yeah, trig's coming. Yeah, not tonight, but it'll be coming. So we'll get there. But yeah, we got a lot to do with this still, but this is a big lesson to get started on. You'll see it a lot. So that's all I got for tonight, guys. I've been trying to keep these to about an hour for the first couple weeks here, while you get acclimated to your classes. As we move forward, some of them are going to be a little longer, but we'll see where we're at. But if these are making sense, then that is good. And then I will see you guys tomorrow to work on some of this. And the plan is going to be to just give you some homework each weekend. So I'll give you something tomorrow, Thursday, and then you'd have Friday, Saturday, Sunday to work on it. And then we can kind of look at it on Monday. Okay. So I got, have a good night.